And welcome back to WCCF Tech, everyone. This is Keith once again, and we're joined today by Rev of NVIDIA GameWorks, and we're going to be having a deep discussion around GameWorks technologies and the use in current gaming situations. So, Rev, you want to go ahead and introduce yourself to the audience so that they can get a good understanding of you and who you are and what you do?
Thank you, Keith. My name is Rev Lebaredian. I am Vice President of GameWorks and Lightspeed Studios here at NVIDIA. Well, here is actually my home right now, but I'll be at NVIDIA in an hour or two. I've been at NVIDIA for about 15 years now, and during my time here, I've worked on primarily gaming technologies. In recent years, we've been not only developing gaming technologies for games in specific, but anything that can benefit from the same core technologies like VR, AR, and now robotics as well.
Awesome. And so as we get kicked off into the questions that we have here prepared, first off, it's been about a year and a half since we spoke with you guys last regarding GameWorks technologies. And can you give us a brief overview of how things have progressed for GameWorks as a whole since then in the past year and a half or so?
We're really happy with what's been happening with gaming in general and our part in it. We've been increasing our investment in developing gaming technologies through our GameWorks group, and in the process of doing so, we've expanded the reach of our technologies. Not only are there more games than ever using it, and not just big AAA titles, but also indie titles and different new games and in interesting genres that are popping up. But these same gaming technologies are being used in new modes of immersion, in VR, in AR, that's upcoming, and we're also using it for simulation for various non-gaming purposes. We recently announced our project in the robotics area. We call it Project Isaac. We're building a robotics simulator based on a derivative of the Unreal 4 engine, and that incorporates all of our GameWorks technologies. It's a critical component of doing this. We've also been hard at work on advancing the field of deep artificial intelligence, deep AI. We're looking at various ways of enabling game developers with specific technologies that are derived from AI. One of the most interesting areas is looking at content creation. A big problem that we've identified in game development is the cost is so high in terms of developing large worlds and content. And so a key problem that we're trying to attack these days is how do we enable game developers to create much richer and larger worlds with the same resources that they have, leveraging all the AI technology and simulation that we're bringing to the table.
That's really interesting. I like the explanation of how deep learning, because a lot of readers and a lot of viewers keep hearing deep learning and they think of it a lot of times as buzzwords, but it's really neat to see that you guys are using that to enhance the gaming side of things as well as the robotics and the AI, but seeing it being used for the gaming aspect is really neat to see how it could help with those large scale worlds, because even games like PUBG, like even though it's one island, it's huge and there's a lot going on there, and knowing that something like that can help a developer like that expand what's going on their islands or in the game world itself.
Absolutely. I mean, we saw deep AI happening really early on. We're one of the first companies to really see this, and a big part of that is because it was happening on our platform first. It was in 2012 when AI techniques started creating records on computer vision. It was all done on our platform, on CUDA and on NVIDIA hardware. So we saw it early on, and we've been investing heavily in it ever since. The way we look at it, deep AI, it's not a field by itself. It's an enabling technology for everything. It's sort of like the way we look at it within our company, every engineer in our company needs to know how to program in some language. They use C++ primarily, or Python or other scripting languages. Every engineer needs to understand AI and figure out how to use that to take whatever they're doing further in their particular domain. So we obviously care about gaming. That's our core. We've always been about gaming from day one, and we haven't lost sight of it. We're going to continue investing heavily in it. If anything, we've been pouring more and more resources into the gaming world because we love it, and we feel that it's also what we do in gaming has ramifications outside of gaming as well. And given that deep AI is important to us, and we feel that it's an enabling technology and that gaming is important, we've been combining the two. This past GDC, we announced a few of the technologies, and we released a few of the technologies we've been working on, sort of a taste of what's to come. It's available for anybody to try on our website. We have a technology to do super resolution, to up-res images and textures and stuff you have to 4 times its size. It does an amazing job of filling in details that aren't there in the original image based on what it's learned from a large database of images on the internet, from ImageNet. We have a texture multiplier, another key sort of technique that's necessary for constructing large complex worlds. Painting textures that aren't repeating in a large world like what you would have in GTA or The Witcher, it's laborious, and it's a very manual task. So we have a technique that'll take a small snippet of your texture and create unlimited amounts of variations of that. And I forgot what was the third one in that list. It'll come back to me, but we have 3 of them that we put out there. We've also showed at SIGGRAPH 2016 and this past SIGGRAPH the techniques for using deep AI for streamlining and enhancing facial animation. So we worked with Remedy in 2016 to take their state-of-the-art, best-in-class gaming or facial capture rig, which involved 9 cameras that had to be calibrated just right, and a whole bunch of post-processing after you've done the capture of the facial of the video for the facial animation to convert it into actual animation of the vertices in the facial mesh. We streamlined that by turning it into a much simplified process where you can take one image, one video stream of the face, and run it through our neural network, and you get the same facial animation out of it. This past SIGGRAPH, we took it a step further, and instead of going from video to facial animation, we now have the ability to go from audio, from the voice, directly into facial animation, which opens up a lot of possibilities. You could potentially create new scripts for your characters in different languages when you want to localize it, and have it all automatically generated without having to have an army of animators do all of the facial animation for every character inside a game.
Wow, that's pretty impressive, because that is a big undertaking. Whenever you're scripting and there's a lot of vocal work in a game, is the facial animations. You spend more time on that than the script or the recording or anything else. And if there can be something to handle that, you could see much more conversation pieces in games, much more dialogue, a lot deeper stories, and like you said, localized for the language. That's huge, because most games are, most are primarily done in English. So if you're in a non-English speaking country, you're getting the dubbed effect, or the subtitles. So that's really neat to see. One thing I saw recently was, and I can't recall who did it, but it was, you could take a selfie, and it would use you guys software in the AI on the back end, and it would actually turn it into a 3D image. And of course I was like, okay, let me see how this works, and I took a picture of myself. I was like, that's creepy accurate. It was pretty scary.
And we're just at the beginning of all of this stuff. the quality and the accuracy is just going to increase. And this kind of technology is going to democratize game development. We've been seeing this trend for years now, where people take existing games and game engines and they modify them to make other new types of games. And we have whole new genres that come out of these things, right? Dota, for example, it came from Warcraft 3 and spawned the whole MOBA genre. Started as a mod. All the stuff we're seeing now with these Hunger Games style games, PUBG, they all were derivative of from other games. I think it started with Arma to DayZ and on and on. So what people really crave, what gamers crave, is the ability to actually create their own worlds and their own games within these rich environments. And what they're missing is an army of artists and engineers who can do the specifics. But what AI is going to allow us to do is not only take the traditional game developers and really supercharge the types of games and the scale of the games that they can build, but it's going to further the democratization of this game development so that anybody can start creating their own rich worlds within the context of what these great game developers are doing. Minecraft is probably the best example here, right? I mean, Minecraft by itself is not really a game. It's more like a platform where people can create their own worlds and their own mini games.
Yeah.
And I mean, Minecraft is great, but ultimately, I think people want more than just 8-bit style graphics. They want to be able to create super realistic and super rich worlds as well. The only thing between that kid playing Minecraft doing that is all of the technical know-how necessary and the artistry, but their imagination is there. They know what they want to create, and so we want to move towards that. I mean, it's going to be a little while, but we're taking steps towards it, and I think these are the first steps that you're seeing with the kind of technology we're putting out there. By the way, I remember what the third one was that we announced, and this one's actually pretty cool. We have a photo to material technology where you can take two pictures of some material, say a rug or a piece of wood or any material you like, and it takes a picture of it with and without a flash. You can feed that into our algorithm, and it'll automatically generate all of the texture maps you need for the parameters of the lighting model to reproduce that same material exactly the way it is in real life. So that's another example of one where, you know, you can imagine any kid who's playing a video game saying, "Hey, I want to bring this material that I see here in my bedroom, this couch or this duct tape or whatever I like, and bring it in without having to be an expert at texture painting, at material synthesis." Currently, that kind of effort for an artist is hours and hours of work. You take a picture of this thing and you have to do all kinds of image processing and fudging it with an artistic eye in Photoshop to produce it. So we want to automate all of that and make it so that professional artists don't have to waste time doing mundane things. They could be focused on creating, working on the high level things that they really care about. And a nice side effect of that is it allows almost anybody to start being a game developer too.
Yeah, that's good stuff. One thing that you mentioned earlier is actually what one of the next questions is you mentioned indie games, and it says the question here is usually we see AAA games implementing GameWorks technology, but lately we've been seeing more indie studios. One is Theory Interactive announced that they'll be using WaveWorks and PhysX in their game Reset, while Exor Studios is using PhysX and Xmorph Defense. So how did the partnership with these indie developers come about? Did you guys reach out to them, or did they come to you, or how did that work?
We've always worked with developers of all scales. We love games in general, and when we see a game that's cool, we don't care, you know, how big the developer is or how well known they are. We'll work with anybody. And so if you look back historically to all the developers we've worked with, you can see it in announcements that we've made over the years on our websites and press releases and whatnot. There's been developers of different scales that we've worked with. We have probably the best developer relations team in the world in the gaming space. We've been building this team for well over a decade now, and we've got guys that have been part of NVIDIA doing this and this alone for the whole time. And so there's virtually no game developer out there that we're not talking to, that we don't have relationships with, and we build trust with all of them. So the way it usually works is, we keep these conversations going. We chat with them at various events and game shows like Gamescom and E3, etc. But outside of that, we also keep our communication lines open with them. And often they'll see something cool that we've done with some other game developer, or just something we've announced in our own demos. They come to us and say, hey, we want that in our game. We think it'll be perfect for what we're trying to do.
Cool.
So yeah, it happens kind of organically. We don't try to push our technology into a game developer who doesn't want it. So we generally wait for them to ask us about it, and sometimes they'll come to us and say, hey, what do you have? There's a whole bunch of cool stuff. Is there anything that you're working on that isn't public yet? And we'll take a look at their game and say, we have this one thing we're working on. It'd be perfect for what you guys are trying to do as an effect here in this game. And it'll go from there.
The next set of questions that we're going to run through, they're GameWorks specific, like the GameWorks specific technologies. So it's quite a few, but they're fairly straightforward questions. If there's anything you want to expand on those, feel free to do so. And if there's, I'm going to go ahead, I'm going to read the questions, and if it's something that you can't go into, because of the nature of the question, that's fine. Just let me know and we'll move on to the next one, and we'll just cut that section out. The next question is, the most recent GameWorks tech demo showcased Flow running on DirectX 12. Is that an indication that you'll eventually add DX12 or Vulkan support to the rest of the GameWorks library?
Yeah, I believe we discussed this the last time I interviewed with you guys, year and a half ago, whenever that was. The plan is to support any APIs and platforms that our game developers care for. So in an ideal world, every one of our technologies would run on every API, on every operating system, and on every piece of hardware, no matter how big or small. The truth is that sometimes technically that's not possible, but also that despite the fact that we have a lot of resources, they're not unlimited. We can't support everything well. So we prioritize which technologies we move to specific APIs based on developer demand. So the two that were in big demand, talking to all of the game developers that we have relationships with, recently were Flex and Flow. Flex is our particle-based, position-based dynamics physics solver that lets us do a unified simulation of various types of physical phenomenon. So you could do rigid bodies, fluids, soft bodies, all combined in one. It's really cool technology. But when we first developed it, it was on CUDA because it required a level of sophistication in the compute API that other APIs didn't provide yet. But the demand for it was high, and people wanted to run it with DirectX, so we ported it to DirectX 12 and released that. Flow is the other one. Flow is sort of our third generation of voxel-based or grid-based fluid solvers. Previously, we had Turbulence, which was based on CUDA, but with this version, we decided, all right, a lot of game developers want it, and they want to run it on DirectX, and that'll integrate nicely with the graphics API, the graphics side of the API, and so we released that as well. And over time, we plan on supporting DirectX 12 with every single GameWorks module, if it's possible, and as game developers request it.
Yeah, that makes perfect sense. If they're not asking for it, there's not a lot of reason to move the resources into that. I totally can get behind that one.
Exactly.
Yeah, another thing we want to talk about today is ambient occlusion solutions. Mm-hmm. So far, we've seen the high-quality VXAO, or voxel accelerated ambient occlusion, in Rise of the Tomb Raider. But we haven't seen it in much else. Is it because of how taxing it is, or should we expect to see more focus on something like HBAO Plus support in the future? Right.
So VXAO was announced with Final Fantasy 15 at Gamescom. Final Fantasy 15 actually has a lot of GameWorks technologies, and they came to us early on asking for our help in making their PC version amazing, trying to push it to the limits. So they were willing to invest in that early on. There's other games that I can't talk about that are potentially going to use it, but it's true, VXAO is a lot more expensive computationally than screen space methods like HBAO Plus. That's the reason why it didn't exist before. AO techniques came from the offline rendering world before we introduced them into games. It started, for CG films and visual effects and stuff, where render times aren't as much of an issue as they are for real time. Screen space versions were introduced because of the real-time computational constraints that we have. We've known all along that it's not ideal. Screen space techniques can't give you shadows from things that aren't in view in the camera. They don't give you shadows from things right behind the first shell of things that you see in the camera. So there's a whole lot of problems in them with it, and it's all well understood and well documented. VXAO solves all of that. But of course, there's going to be additional computational cost. When the way we work, we look at what the future of gaming is, what the future of computer graphics is, way out, well before anybody else starts thinking about it, because we have to decide where we're going to place our bets when we design an architecture. When we create a new GPU architecture, we invest billions of dollars in the development of it. And it starts early. It starts, 3, 4, 5 years out. And so my team on the GameWorks side is often asked by our architecture guys, what's coming? Where should we put our transistor budget to take it to the next level? And so we try to identify these things. VXAO and VXGI were possible because of specific features that we added to the Maxwell architecture. We were under no illusion that day one when we released this thing that there's going to be 100 games out there that are using it, because it's just cutting edge and it requires modification to your engine, and the cost is high. But if we don't do that, if we don't put it out there for people to start experimenting with and playing with, then it'll never end up in games. So we're playing the long game. We develop these technologies trying to envision what we want to see in terms of computer graphics years from now, and then we put our money where our mouth is. We develop not only the hardware for it, but the layers of software, and even up to the integration into the popular game engines, so that game developers can benefit from it whenever they're ready.
Cool. That's good to hear. That let you know that there is a future for it. It's forward thinking. May not be able to handle it like at launch day, but knowing what could be coming and what they have available, so that whenever they're able to take advantage of it, the tools already exist. They're already out there and can be put to use.
Yes, I mean, a game developer. It makes sense if you're a game developer, to not look at what's coming 5 years from now. Ultimately, you need to sell your game, and nobody's going to buy it if they don't have the hardware to run it.
Very
So
true.
day one of a release of a new GPU, nobody has it yet, so it doesn't make sense for them to put all of their eggs in that basket. That's why we do what we do. We'll do a lot of the work for them to because they can't justify the cost on day one, but it'll demonstrate what's possible. And then a few years from that point, when we have another generation of GPUs, that generation will become kind of the older one, and the install base will be larger, and more people will be able to use it.
Sounds good. One thing similar to lighting that we're going to come to, we all agree here on the site that the volumetric lighting in Fallout 4 was great and looked incredible once it was implemented. Are you seeing other developers interested in using the same thing for their games?
We are, but unfortunately, I can't talk about unreleased games
Absolutely.
and technology. So,
hey, all we like to hear is that people are looking at it. So it's just something we'd like to see more of. That was a group question that they wanted me to throw in there and ask you about.
Of course. But I have to give you the standard.
Oh, absolutely. Hey, sometimes
I can't talk about unreleased stuff.
Yeah, but there's hopeful. The next question is kind of it's a shotgun of a question, but it's revolving around anti-aliasing, such as TXAA. Will that remain a main anti-aliasing solution within GameWorks for the foreseeable future? And then moving on to something which I'm actually a huge fan of, and if anybody out there is bothered by me being a fan of this, that's fine. But it's multi-res shading that we've seen in Shadow Warrior 2. Seeing that take place outside of just VR functions was great. I thought it worked out really well. I saw a huge performance change, and really the idea behind where you're focused on the screen, and especially in a fast-paced shooter game, and being able to degrade the edges slightly to take a huge performance leap. I loved the fact that you could do that. And then games like Watch Dogs 2 used a similar technique in the checkerboard rendering to be able to run higher resolutions and maintain a better frame rate. What do you want to expand on those things?
So anti-aliasing in general is a core fundamental problem in computer graphics that will truly never be solved, because fundamentally what we do in computer graphics is try to create a discrete representation of something that's actually continuous in the world. So the real world has it doesn't have pixels. We don't have samples, but we're forced to do this. And whenever you start sampling and converting things into continuous functions into discrete ones, you're going to have aliasing. There's no way around it. In the real-time world, what we're always trying to do is find this a set of trade-offs that we can make to get performance to the right place, but maintain quality. And as we've gotten more and more horsepower to render more, it seems like we're still not willing to do more aggressive types of anti-aliasing, super sampling and whatnot. We take that budget and we apply it to other things to add more complexity. So we've created a bunch of hacks for various AA techniques, which is fine. All of computer graphics is a series of hacks. The real world is very, very complex, and the physics of light are virtually impossible to simulate exactly, given the computational power available to us in the world, or will ever be. So what we do is we do approximations, and TXAA has been a very successful one. It's the trade-off for quality and performance have been good, but it's by no means the end. We continue to invest in more and diverse anti-aliasing techniques. We can see a potential for using AI in this area as well. This past SIGGRAPH, we showed some techniques in the ray tracing world on denoising, which is a related problem, and so there'll be a lot more to come. On the multi-res front, that's a really interesting sort of path that we started with Maxwell. The Maxwell architecture allowed us to do this rendering at different resolutions in different portions of the screen, but it was somewhat limited to a 3x3 grid the way we're doing it. We enhanced that even more with the Pascal architecture, and we really feel that given the resolutions we have to go to now, 4K, and there's 8K coming up on the horizon, what VR requires in terms of richness and complexity, there's no way to do that well without having some way to vary the sampling rate across your image. If you render everything at the full resolution, you're wasting a lot. So we continue to invest there, and you'll see in our future architectures that it's just going to get better, both in terms of quality and also easier for developers to integrate into their pipelines.
Cool. That's good to hear. No, I thought it was, whenever I played through Shadow Warrior 2, I was like, this is really cool, because that was about the time that I was trying to run every game at 4K.
Yeah, I mean, in an ideal world, the idea comes from all of this research that's going on the VR side, and what's called foveated rendering, where you render, you take more samples in the region of interest. In an ideal world, we would actually know what you're looking at. If there's some way for us to track your gaze and know what part of the image you're looking at, then we can increase the resolution in that area and decrease it in the areas that are in your periphery. Currently, there's technologies for that, but they're still kind of nascent. But it's not hard to imagine that sometime in the not too distant future, you'll have your webcam or some device actually tracking your gaze, and you get the effective resolution of 8K, but render with a fraction of the number of samples to get there.
And that would make sense. It's the same thing as not rendering what you can't see. So it helps, even if people want to call it a hack or whatever. It helps, and if you're not going to see it, but it improves what you can see, where's the downfall?
Precisely. I mean, why would you render anything that's off screen or behind another object, right? All of computer graphics is about doing those hacks. Their optimizations don't do work that's not visible.
Exactly. This one may be a I cannot disclose question, but it would be a fun one, and a lot of people would like to know. It's Rev, can you disclose whether the Nintendo Switch hardware or software have enhanced support for GameWorks when compared to the standard Tegra X1?
You already know what the answer to that is. You need to talk to Nintendo if you want to get information about their product.
I figured that was.
I can say that they're a great partner, and we love working with them. And I think the feeling's mutual.
Well, that's good. That's good to hear. Definitely, I couldn't go without asking. It was in there, and I knew if I didn't, they were going to get me for not at least trying. Another question that is interesting, and especially in the landscape of the way things are going in the monitor scene, would like to know, does the upcoming display revolution with things like G-Sync, HDR, wide color gamut, does that in any way change the approach to GameWorks, or is that a very separate thing?
So GameWorks is very broad. We have technologies under the GameWorks umbrella that span, physical simulation, rendering techniques like shadowing and ambient occlusion. We have Ansel and shadow play highlights. We've got all kinds of stuff in there. So there are potentially aspects of GameWorks, some things that might be affected by the end of the graphics pipeline where HDR lives, but there's a lot that aren't. For example, PhysX, which is our core simulation, physics simulation middleware. That has nothing to do with HDR. Obviously, it drives animation that feeds into the graphics pipeline, but much earlier in the game engine pipeline. But for the ones where it does touch the end of the graphics pipeline, for example, Ansel potentially is affected by HDR. It supports HDR. So of course we incorporate that in there, and that's kind of the one of the most important reasons for why we have GameWorks as it is. All of these different disparate technologies are interrelated at some level. So having one company put a lot of resources in doing all of them lets us create something much greater than if we just worked on little pieces individually, separately.
Cool. So that's good to know. That was something we were curious about, is the impact of one on the other. Well, Rev, that's actually about the conclusion. We covered all the questions that were in here that we wanted to talk about today. And we wanted to close it out with a thank you for coming. Thank you for coming on here and taking the time to do this. It meant a lot to us, and it's been in the works for quite some time. We've been dancing around for quite a while now. It's glad
everybody's so busy these days.
I know. It's just I'm glad we finally were able to sit down and get this taken care of.
Same here. This is a lot of fun.
Oh, good. Thank you. It was a lot of fun having you guys on. One thing that we wanted to close out with was give you the opportunity to add anything or share anything about NVIDIA GameWorks with NVIDIA and PC gamers as a whole, and we'll close it out that way.
Sure. One thing that I've been thinking about a lot lately is how all the work that we've been doing, that I personally have been involved with over the years in gaming, is now so critical in so many other important areas. With VR and autonomous vehicles and robotics starting to happen, what we're finding is that all of this technology we build for the enjoyment of gamers is actually really useful for a much wider set of things. So what's exciting to me is that not only is gaming helping the development of these new fields, but I feel like it's going to circle back. So, for example, we've been investing in physics for gaming for well over a decade now, and we continue to increase our investment there. We've always felt that as important as graphics is, we need the behavior for things in these virtual worlds we're creating to feel realistic and be correct and rich. But at some point with games and gaming development, you can reach a sort of good enough. We don't have to be completely accurate with our physics, because some cheats are okay, or we're willing to deal with things like interpenetrating objects. You place an object on a table and it kind of sticks through it and whatnot, for the sake of performance. In the early days, it was absolutely necessary that we had these kinds of cheats for performance. We just didn't have enough computing power to do it right. But now that we've kind of accepted it in the gaming world as normal, there hasn't been a lot of motivation to fix these things. But as we take these gaming technologies and move them into new spaces, for example, our robotic simulation, these sorts of things aren't acceptable anymore. Or when we go into a VR world where you can look at objects up close and expect things to be more realistic and immersive, the cheats that we've done break. So that's been forcing us to invest in taking physics and our gaming technologies in general to another level. And I feel like it's wonderful for gaming, because all this work that we're going to do that we probably wouldn't have done for some time is going to filter back into games and just enhance the experience overall. There's this virtuous circle that's happened.
Well, very cool stuff. Definitely look forward to seeing what we've got coming in the future. Everything out right now is exciting. Really excited for Final Fantasy 15. It's something we've been talking about behind the scenes.
It's a great game, and the PC version is going to be really awesome.
I almost gave in and bought it for my. And I know people are out there, but I've got a Blu-ray player that also plays Xbox games. And I almost broke down and bought it for that, and then I saw the announcement come through, and I was like, "Oh, I'll wait. I can wait."
Yeah, the PC version is going to be the best one by far.
Well, cool. Well, Rev, again, I can't thank you enough for coming on today and sharing the information, answering all the questions, and spending time with us. It's been great.
It's been a real pleasure. Thank you very much.
All right, and we'll catch everybody in the next one.
Take care.